Good morning, everyone. We'll go ahead and get started on our training today. Probably need about 45 minutes today, so we'll try to keep it under an hour for you. My name is John Pendleton, and we're going to cover the TXV and the reversing valve today. If you have any questions, feel free to raise your hand, type out your question, and I'll get to it when I get to a stopping point. Or you can wait to the end and we can answer those questions at the end. I've also got, at the end, I've got my email address. So if you need any of this training material from today, or you have any questions or anything like that, you can shoot me an email or give me a call. This webinar is recorded today. So sometime this afternoon, they'll send us the recorded copy and we will upload it to our YouTube channel, which is Enertech University. And you can watch any of our past webinars, or if you happen to miss a future webinar for some reason that you signed up for, you can go back and look at it on YouTube. There's no charge for any of that or anything. So you can go check out some of our past webinars, or any future webinars will be there as well. That's me, little bald-headed guy there. I'm tech support. I'm also the senior head trainer at Enertech. And here is my direct phone number. Is the first phone number listed there, that's 618-690-3275. And then the number next to it, that 664-5860, that number will call back to tech support. So that'll ring into a pool of, there's 5 of us back there. So if you have a technical question, you can just call that line and the first available technician will give you a hand. Make sure we've already checked, water flow by performing the pressure and temperature differences. We've done heat of extraction, heat of rejection on the unit. Obviously, you got to have airflow, so you can check your temperature difference. Make sure if you've got a zone system that the zone dampers are all open. And there's no restrictions in the ductwork. Go ahead and do the heat of extraction, heat of rejection calculation. Obviously, if it works out correctly, within 10% of the book, then there probably isn't a TXV issue, so we wouldn't need to check our refrigerant gauges. But just make sure you're always checking heat of extraction, heat of rejection first. If you get let's say you get a low pressure lockout, don't just immediately put your refrigerant gauges on there. Make sure you've got water flow and your airflow, and that you're checking the performance of the unit. Basically, what we're going to cover is how the TXV works, the 4 possible causes of the TXV failure, which are normally flooding, starving, hunting, and restricted. So that's what we're going to cover on the TXV today. Basically, and this is a TXV, kind of a cutaway of the valve itself. You've got basically a spring pressure forcing the piston up, and you've got the sensing bulb that's basically pushing the piston down. So as the bulb heats up, it drives that valve open and pushes that piston down, allowing more refrigerant to flow through the valve itself. This is basically the heating mode TXV operation. Obviously, with a geothermal unit, we're looking at a lot of different water temperatures. And so we've got to be able to adjust on the fly, basically. With a fixed orifice piston, that's not very feasible. So basically the job of the TXV is, as the conditions change, it's going to adjust to try to maintain its superheat. That's what the TXV bulb is doing, is trying to maintain the superheat. So when you're checking superheat, we normally will check it pretty close to where the bulb is mounted on the suction line, which is normally about 6 to 12 inches off the suction of the compressor. Basically, with an expansion valve, an increase in suction line temperature increases the bulb pressure. thus opening the valve to allow more refrigerant to flow through it. Again, as the pressure increases in the evaporator, then it'll start to close off that valve. Obviously, it's a more higher accuracy refrigerant charge is more critical with the fixed orifice. So with a TXV, if we overcharge, it'll basically just stack up the refrigerant behind it and store it in the condenser. I mean, it's not the perfect situation, but it will somewhat adjust for an overcharged system. Normally, the most visible indication of proper expansion valve movement or action is suction pressure variation. So if you were to pull the bulb off the suction line and you heat it up, and you're going to get, let's say, 115 psi on your suction. And then as you cool it off, it's probably going to drop down about 5 psi or so. That's normally the best way to know if a valve is actually, throttling back and forth, that the piston's not stuck in some certain position. Just to heat it up and then cool it back down and see what your suction pressure does. There's 4 modes of TXV failure. There's flooding, where it's feeding too much refrigerant, so it's basically stuck open. Now, I've been with Enertech for about 8 years now, and I don't know if I've ever had, when I've been with Enertech, a valve that's been stuck open. And the reason being is, when we looked at that cross section of that valve, we've got that big spring at the bottom, and then you've got bulb pressure on top. Well, the spring pressure is always greater. There's a lot of force on that spring. So if a piston gets some sludge build up on it or whatnot, the spring is enough to push it up, but the bulb pressure is not enough to push it back down. So normally 99% of the time, the valve's going to be stuck closed or stuck mid position. It normally won't be stuck open. It's just very rarely seen. There's starving, where it's not feeding enough refrigerant, so it's stuck closed, stuck, in some certain position, and that's going to be your most likely failure. If you've ever taken one of these valves apart, you can actually take the head off the valve and not lose refrigerant. And you can actually take that head off that TXV, you can turn it upside down, and there's a little disc inside of that head. And you can kind of tap on that disc. If that disc is loose inside of that head, then the bulb has lost its pressure, because that bulb has refrigerant in it, and it pushes up against that seat on that disc, and it'll be real tight. So if you happen to have a bulb, the line break, or lose the refrigerant charge somehow, then the valve doesn't push back down, so you're going to get stuck closed. You can just change the head of some of the valves. Now we're getting into some newer valves where we can't just remove the head, but I know, like on the XT, the WT, the YT, those all have a TXV head that can be removed. So if you just want to change the head because the bulb line rubbed on something else and bulb lost its pressure, you can file a warranty for that if it's under warranty, and just replace the head rather than replace the whole body of it. Hunting, basically it's alternating feeding too much and then too little. Reaction is very quick. So either the bulb has lost its charge, the equalizer tube could be plugged. A lot of times you'll see, your 2 refrigerant lines coming in, and you've got a little either 1/8 or 1/4 inch line coming in the side of the valve, which is an equalizer tube. Basically, that equalizer tube is there to keep the pressure equalized where the piston is, so that piston can move up and down. If that equalizer tube gets plugged, maybe you're replacing a valve and you're new at brazing or something, you get too much brazing material in there, the valve won't be able to move. The piston inside of the valve will not be able to move because of the different pressures that are in that valve. So the equalizer tube in the TXV is there to keep an equalized pressure in the valve so that the piston moves up and down. Now that equalizer tube will also help equalize pressures when the system is off. but that's not necessarily what it's there for. And then we have restricted. Restricted is going to be, you could have an orifice, you know, maybe the older valve had a spring in it or a screen, and that screen is plugged up. And when that happens, it could be stuck in any position. But normally, again, that spring pressure is going to slam that valve shut, and that's what you're going to get. You're normally just going to get a valve stuck closed. Flooding symptoms. Basically, this would be a expected superheat and subcooling range on a unit. Normally 6 to 18 degrees on our superheat, and on this unit about 11 to 29. Now, in our manuals, we do list what we have a troubleshooting section towards the back of the manual, and it will list, you know, refrigerant charge ranges, superheat and subcooling ranges. And then in some of the extended data tables, we'll list exactly what the superheat should be. Not all of our manuals have that, so it's kind of, it can be a little bit deceiving that I'm telling you this, but some of them do have on the extended data tables at, let's say, 80-degree entering water temperature, what your superheat and subcooling should be. But we will always give you a range in the troubleshooting section, so look at that. If you don't have a manual, you got no way to pull one up, and you don't have any phone service, so you can't really call tech support, a good rule of thumb with our equipment is 10 degrees superheat and 10 degrees subcooling. If you can get it, you know, plus or minus a few degrees here or there on either side of that, normally the unit's going to be properly charged. Another way to do it is look at the nameplate and look at the charge amount on there. And if you need to put charge in it, you can pull the charge, weigh the charge out, and weigh the charge back in. Normally, when we have a TXV that's stuck open, we're going to have high suction pressure and low discharge pressure. So we're going to have low superheat and low subcooling. You can see the kind of line we've made on this diagram here, and that would be the proper charge amount. So we should see, you know, the blue underneath that line and little bubbles above it, and the red on the right side should be up to that line as well. Obviously, make sure we're always verifying proper water flow and airflow. Water flow will have to take pressure drop or use a flow meter or something like that. Airflow, if it's an ECM, you can actually look at the ECM board and you can count your blinks, and that'll tell you how much CFM you're moving. Symptoms of a flooding a TXV. So you could have some frosting of the compressor shell, normally pretty near that suction line there. The compressor could be noisy and pulling high amps. You're going to have low superheat, and you're going to have higher than normal suction pressure. There's some frosting of the compressor. You can kind of see, obviously the head is going to be hot, so the frosting is going to be lower on the compressor. You can see kind of the frost on that suction line coming out of going into the compressor there. It's going to be rattling around. It's going to be noisy. It's not good on the compressor. You're going to have a high amp draws on the compressor. You can try to adjust the valve on if you know your superheat or your superheat is off. Most of our valves are adjustable. Now we're getting into, again, we're changing up valves and new equipment, things like that. And some of them are getting away from the adjustable expansion valves. Now we set the valves are set to maintain superheat when you get them. So if you think that you need to change to adjust it, you can. It's that bottom nut in this picture. But remember where it was when you started. So count the amount of turns that you turn it. That way, in case we need to go back to where it originally was, we know how many turns to get it back there. I would probably call in tech support and get our opinion on it. And we'll look at some water flows and air flows, obviously, and then give you our recommendation I don't ever recommend that a valve be adjusted, but you can definitely try it. It's not going to hurt anything. If the unit's not operating properly, it's not going to, I mean, it could help, but it's not really going to hurt it anymore. So if you ever need to take a TXV valve apart, I just want to show you on this picture because it kind of shows it kind of a little bit more clear. You can see the body has some notches on it, so you can back up the valve. Always back up the valve when you're taking any of the either the adjustable set screw nut off or the main valve body nut. Make sure you're always backing up that valve. So you can take the head off because it's got notches on it as well. You can use an adjustable wrench on that. And then the nut that's right above where the adjustment screw is, if you happen, you wouldn't want to do it with no refrigerant in the system, but if you take the refrigerant out, take that nut out, there's going to be a spring, a disc, and then your piston is up in there. In a pinch, on the weekend, if you don't have a TXV and you've got a TXV that's restricted, as long as the bulb is still good, normally the piston just gets some gunk on it, and that's what causes it to get stuck. So if you were to take the bottom nut off here, pull that spring and disc seat out, you can pull that piston out and clean it up and put it back in. There's nothing really inside of the valve that breaks. It's just, it gets almost like a honey colored gunk on it, and then it won't allow it to move up and down. Sometimes it gets real sticky. If you clean it up and put it back in and you happen to have some AC renew, you can normally get that valve to work again. So in a pinch, on the weekend or something, you need to get them some heating or cooling. That's definitely an option. If you got any more questions on that, you can give me a call. We can kind of discuss it one-on-one. This is a scroll, the internal workings of the scroll. So if you have flooding, this is what the scroll should look like, and this is what flooding can cause. You can see a lot of pitting, etching of the actual scroll. So flooding, we can't really compress the liquid, and so it causes etchings and things like that of the scroll itself. Starving, basically, we're not sending enough refrigerant, so your superheat will be high and your subcooling will be high as low. Again, in this picture, that yellow line in the middle is the proper charge. So if we're starving, then we're not feeding enough refrigerant, basically. Again, we're saying good rule of thumb, somewhere around 10 degrees, superheat, subcooling. So as you can see in this picture, we're going to be high on both superheat, subcooling. Some of the causes of starving, you could have moisture in the system. If you get a lot of moisture in the system, let's say you have a heat exchanger that is breached into the refrigerant circuit, you're never going to get all that moisture out, so it's probably a lost cause. We're talking a little bit more about a minor moisture in the system. Maybe you got a little bit of moisture in there when you were doing some brazing or something, but it can get inside that valve and freeze up and cause that valve not to throttle. Obviously, debris. We don't have a screen in our TXVs any longer. So if you get debris in there, if you have an acid burnout on a compressor, if I had an acid burnout on a compressor, I would recommend changing the reversing valve and the TXV. And you can put that on, if it's under warranty, you can put that on the warranty, and tech support will never tell you, we'll always give approval, let's put it that way, because warranty is going to ask tech support, and we will always say, yeah, go right ahead, change both. We would much rather have you change those while you already have the system open than if you were to change a compressor, start it up, and then realize that those components are bad. I know it doesn't make you guys too happy when you have to do a job twice, so let me go back. So yeah, if you ever have a compressor that you think is an acid burnout, then go ahead and change obviously the filter dryer, and you can change the expansion valve and the reversing valve too if you would like. A restriction on the inlet. So if the filter dryer is before it, you could have a restriction there, and you can check temperature difference across there to see if it's restricted actually in the filter dryer. But again, clogged strainer, if there is one, if it's older than about 5 years, it probably has a strainer. If it's newer than that, it probably does not. But it doesn't really matter. You can't really take that strainer out. You'd have to change the whole valve anyway. I think that's probably why they quit putting them in there. Obviously, low on refrigerant. The piston is stuck in a closed position, or you could have loss of bulb charge or bulb input if we have an electronic expansion valve. Moisture and debris, obviously both can cause the TXV from opening properly. Make sure we're always changing the filter dryer when we have the system open, and keep this system open for a minimal amount of time. You know, don't open the system, realize you're out of nitrogen, leave the system open and be gone for a couple hours. The oil that's in R410, it loves moisture. If you've ever gotten it on your hands, you'll realize it sucks the moisture right out of your skin. And matter of fact, they put it in a metal canister because it will actually draw moisture through if they put it in plastic, it would actually draw moisture through the pores of that plastic. So make sure if you have to put oil in the system that you keep that canister, you don't leave it open as well. You can also install a liquid line moisture sight glass. It'll tell you if it does have moisture in it, and you can kind of address that. But yeah, make sure we're trying to get as much moisture and debris out of that system as possible if you've got to open it up. Obviously, loss of bulb pressure, then we're not going to be forcing that piston down. That spring pressure is just going to force that piston to stay where it's at, which is closed. Hunting symptoms. In a hunting situation, you could have a valve oversized for the application. As long as you get the valve from us, you shouldn't have to worry too much about that. We're pretty good about sending you out the right parts and installing the right parts on the line. So I've never seen us, have put a wrong valve in a system, but definitely could be oversized. Bulb location and contact with pipe. I see this a lot on split units, especially with those Mortex air handlers, where the bulb is just out there hanging in space, and it needs to be strapped to the line and well insulated. So I've also walked into package units before, and they've got the bulb taken off the line, and it's just kind of hanging out there in spaces too. So make sure it's usually above the 6 o'clock position on the piping. So we're out of the oil line, so we're actually sensing refrigerant temperature and not oil temperature. And make sure there's no insulation in the way, and that clamp is tight on that bulb and the pipe, and it's well insulated. Again, moisture in the system can cause some hunting, as well as non-condensables in the system. If you have a split system with the ball valves, and you put too much pressure on the line set when you're testing it, you can get some non-condensables because you can get some of that nitrogen pushed back in to the refrigerant circuit. So like on split units, when we're testing line sets for after we braze those in, don't go higher than about 150 PSI. You could have an equalizer tube that's plugged or kinked and not allowing that piston to float up and down normally. Basically, what you're going to see as fluctuation of your leaving temperature on your evaporator, that's where you're normally going to see that at. So that's basically, with the 1/4-inch lines that come into some of these valves, it's a little bit harder to plug them up, but we have some real small, newer valves that have like almost like a stainless steel line, and it's not even an 1/8 inch, it's like a 1/16 inch. So it's a lot easier to plug that up. Normally when I see them get plugged up, it's when you have to change the valve and they braze on it. And they'll put too much brazing alloy in there and it'll plug up that tube. So just be careful when you're brazing that. It doesn't take much to heat that up. And so just be a little careful when you're brazing on that 1/4 inch line. A restricted valve. So really it's going to depend on where the valve is restricted, but normally what we're going to have is we're not going to feed enough refrigerant in the evaporator here. And the result will be a high superheat and a high subcooling. Basically, if we've got a restricted inlet on the TXV, flash gas is created at the TXV inlet. So you could have some moisture or frost on the liquid line on that valve. I don't see that a whole lot, but occasionally I will see. It's normally not frost, it's normally just moisture. Basically, as that flash gas is formed, it basically causes a refrigeration effect, making that area around it cold. Since the liquid is normally warm to the touch, excuse me, it's obviously a sure sign that there's a restriction. Now, if you get a restriction in a filter dryer, sometimes it'll do the same thing. It depends what the restriction is and how far it tapers it down. So usually, like on a filter dryer, the best way to know if you've got a restriction there is temperature difference. You know, you shouldn't have but more than a couple degree temperature difference across there. So on a filter dryer, if you got a large temperature difference, you know that you're basically having that refrigeration effect take place right there. Fire and ice testing procedure. Basically run it heating and cooling. It doesn't really matter whichever mode you're in at the time. You're going to remove the sensing bulb from the suction line, remove it from the installation, remove it from that strap, and place the sensing bulb in a glass of ice water, and you should see your suction pressure drop about 5 psi or so. You can also take it out of the ice water, and you can set it on top of the compressor where it's hot. And then drive it again and watch that pressure and see if it's opening. Basically, is all you're doing is seeing if it's opening. If no change in suction pressure, TXV is not responding and will need to be replaced. We do have a TXV troubleshooting video on our YouTube channel, and it's right here, and it's maybe a 5 or 10 minute video. And we're going to be looking at this little blue suction gauge here and watching to see if it drives. We won't watch it today. We'll go ahead and move on to the reversing valve. Basically, you know, we want to make sure we're always checking water flow first. Water flow is obviously the hardest thing to check because we've got to have, you know, pressure drop or a flow meter. And so you can't really see the water flow or feel it. So make sure we're always checking water flow first and make sure we've got airflow if it's a forced air unit. If it's a water-to-water unit, make sure that you're checking the load side water flow as well. We've got to have PT ports on a water-to-water unit on the load side because we've got to be able to establish water flow on both sides of the equipment. So make sure we're always installing pressure temperature ports. When in doubt, install a PT port. They're a lot easier to install on initial, you know, installation than they are if you have to go back and put them in. It makes it kind of hard on us on tech support when you guys call in and you know, we ask for pressure drop and you say, well, it doesn't have PT ports. The only other way to really establish flow is to disconnect the system and drain it into a 5-gallon bucket and see how long it takes to fill that 5-gallon bucket. So it's not a real good way of going about doing it. So make sure installers are always installing them. Basically, a reversing valve in the system is switching from heating to cooling. If you've ever seen a combo unit, we have another directional valve in the system that looks just like a reversing valve, and that's because it is. It's just we're calling it something else. It's actually the same part number, but basically it's just switching from one mode to the next. You can see here in heating mode, the discharge coming in through that middle port and going to your air coil. In cooling mode, we're going to go to the coax from our discharge. And then you can see the heating and cooling modes, basically the refrigerant circuit. If you've got a water-to-water system, you won't have the air coil on the left. You'll have another coaxial heat exchanger there. The system doesn't really work any different as far as the reversing valve goes, whether it's a water-to-water, a packaged unit, a split unit. They all work the same. They're powered in cooling mode, so they fail the heating. Basically, it's a three-way pilot valve. You can look at the top of this cutaway here where you see little squiggly lines. That's indicating your solenoid coil. And then your pilot valve is next to that little black boat-looking thing in there. And the solenoid does not actually switch the valve over. It allows that pilot valve to move, and then your discharge pressure actually pushes that valve over. Basically, the temperature of each line is a way to tell if refrigerant is bleeding by. So you can see this is the discharge pressure coming out of the discharge line. If you look at your system, you'll see a little pilot tube running along there. Basically, the discharge pressure comes in. Depending on where the pilot valve is, it's going to allow the discharge pressure to go on one or the other side of that slide on the reversing valve. So that discharge pressure actually slides that valve over. So if your pressures are equalized, the valve will not shift. So if your compressor's not running and you energize the valve, you may hear it clicking, but you won't hear the valve switch over, and there won't be any swishing going on because the pressures are equalized. So there's no difference in pressure. Normally you should have suction pressure on one side and discharge pressure on the other. So the discharge pressure is going to be, 300 psi, and your suction maybe 100. And so 300 is greater than 100, so it's going to slide that valve over. You could actually have one of these pilot tubes get plugged up, and that's why I say if you've got a burnout on a compressor, a lot of times they'll get stuck on these little pilot tubes, and then the valve won't shift. Obviously, your discharge and your air coil line, in this example, should be the same temperature, plus or minus a couple degrees. And then your suction and loop field connection should be the same temperature. So that's a good indication if you've got bleed by through your seals is temperature. You can see the solenoid's energized. It moves the pilot valve, allows the refrigerant to now the discharge pressure push on the other side of that valve and then push it over. The valve is not energized in heating mode. Always fails the cooling. Most manufacturers do that. There might be one or two that don't, but so basically this is the pilot, the root of the refrigerant in the pilot tubes in heating mode. So you can see the path of the refrigerant flow in our heating mode. In cooling mode, the valve is energized, O is energized, it moves over the slide, bleeds the refrigerant through, and pushes that valve over. So now your discharge goes through the loop field, and your suction is going to your air coil, or your air coil is going into your suction. Failed solenoid coil, basically during an O-call, the solenoid coil does not respond. Fail safe to heating, you can ohm out the coil. You can also just replace the coil. You obviously don't have to replace the whole valve body, which I'm sure would make a lot of people happy because reversing valves are a pain in the butt to replace, especially if you don't have a lot of brazing experience. your first brazing experience probably shouldn't be on a reversing valve because you'll melt the insides of it. It's really hard to braze on 4 different lines and not overheat the valve. So you got to be real careful. A lot of times I'll braze on one, let the valve, cool off, and then go back and braze again. I mean, I've used the gel before that you can spray on, the thermal paste, rags, just about everything. I'm not a huge fan of the gel only because if you get one drop of that gel on someplace that you don't want it and you need to braze, that gel's pretty good and it won't allow you to braze right there. So you have to clean it all off with some alcohol and stuff to get it out of there. I like the paste because I can control it a little bit better, but it's all, what you're more comfortable with doing. Wet rags, be careful with the wet rags because you can actually dry them out and then catch them on fire. But rags will work. Just be real careful when you're brazing on the valve. One thing on a side note, if you have a reversing valve that's stuck and it has to be replaced, you can request what we call a spider assembly on the warranty. And if we have one available, we will send it to you. And basically, we're going to braze on at the factory some copper lines, and then you can cut them off wherever you need to at the in the field and braze away from the valve. You can get some slip couplings and braze it in wherever you need to away from the valve so you don't get it so hot. But you'll have to mention that on the warranty when you file it, and we'll get you one if we have it available. The first thing you want to do if you think that the solenoid valve is not operating properly is to check for a voltage. I mean, it's pretty simple. You can remove the wires either on the lockout board or on the valve itself and check to see, give it a cooling call and check to see if you have 24 volts between common and O. If you do have power to it, you can ohm out the coil. If it's open, then we know that the coil is shot and will have to be replaced. As long as we haven't changed the reversing valve in the system from the one that you have in there currently, then we can just replace the coil on it. Refrigerant leak, the biggest place I've seen refrigerant leaks on these is in the pilot tubes. And normally they're on the water-to-water unit and they've got a lot of vibration in the unit. If you get a lot of water-to-water units, I say that because guys run them too hard, too high of water temperatures, which causes vibration, which in turn causes these pilot tubes to snap off. What's hard is they're really hard to see and they don't leak a ton, or they don't lose a ton of refrigerant out of them. So you're not going to see any oil. You're not going to see that. So it's a little bit difficult to find those. I've also seen on the end bell of this valve here, I've seen it's almost like a soldered joint, and I've seen them leak there before as well. Normally, they're pretty reliable. We don't have a whole lot of them leak or fail, but refrigerant leak would be one of the problems with the valve itself. If for some reason it's leaking right at the base of the valve body where one of these tubes comes in, that's kind of a pressed in fitting and there's no real repairing it. It's brass to copper. You can definitely attempt it, but you may or may not have any luck doing that. If it's sticking in heating or cooling mode, so it's, could be debris. Again, that's why I mentioned the acid burnout in the compressor. That's probably going to be the biggest cause of debris getting in there. And it just basically won't allow the valve to shift all the way, and we're going to get a little bleed by on that. So normally, if the valve is stuck, somewhere mid-position, you're going to have higher than normal suction pressure and lower than normal discharge pressure. So if the coil ohms out and you're getting some bleed by or it's not shifting at all because of debris, you will have to replace that valve. I'm not really sure what happened there, but hang on a second. Okay, sorry about that. I'm not sure what's happening in these pictures here. Sorry, guys. I think I'm having a little technical difficulty. So sticking mid-position is probably the most common thing that does happen with the valves as far as when there is an issue. Now, I'm not saying we got a whole lot of issues with the valves themselves. They don't really fail that often, normally because we don't shift them but once or maybe twice a year. Usually the refrigerant pressures will be close to equal on a valve that's stuck mid-position. They won't be exactly equal. So that's, if they're both equal, that could be the compressor's not pumping. But normally there's going to be like 130 and 175 or something like that. It won't be like 150 and 150. They'll be a little bit off of each other. Temperature is going to be a good indication because if it's sticking mid-position, most of your refrigerant lines are going to be probably all about the same temperature. Here's basically a little bit better picture of it. Again, you're going to have some bleed by over in your suction over here. There could be you could overheat the valve from when you brazed it in. There could be a dent in it or something like that, but normally it's caused by something either wrong with the seals in it or you've got debris in the system. A lot of times what will happen, the compressor is going to be noisy, rattling around, and it's going to sound like a scroll compressor running in the wrong direction, and your amp draws on your compressor are going to be low. Inside seals leaking, again, you're going to see some temperature differences here, normally caused by overheating of the valve. Let the unit run for about 10, 15 minutes if it will, without going out on internal overload or something like that. And then we can go ahead and measure across the suction and the water coil, and then the air coil and the discharge. Should be less than a 6-degree temperature difference across those. So if we've got more than that, then we know that we're bleeding some of that discharge gas over into our suction side of things. It says never hit a reversing valve with a hard object. If it won't shift, you're not really going to hurt it too much by tapping on it. I'm not saying take a big sledgehammer to it, but you can tap it. I probably wouldn't hit it with the hard side of the hammer. I'd probably hit it with the rubber side, the handle side, but you can tap it, see if it'll do anything. You may have luck. I've seen sometimes where you can energize the valve, get a great big, like a heavy duty magnet, and grab a hold of that valve and try to slide it when you energize it, and you may get the slide over. You can also buy little bitty like round earth magnets. If you ever want to see if the valve is moving or not, you can put those little magnets so they will only stick to the little end bells of the slide on the reversing valve on the ends of it, and it'll stick through the brass. As that slide moves back and forth, your magnets will move with it. So you can kind of see if the valve is traveling at all. But I wouldn't really recommend hitting it hard with a hammer, because it will, if you dent it, then it's definitely not going to slide. Make sure when we're brazing or when we're cutting out components from a system that we're using pipe cutters only. If we use a Sawzall, those little filings from there will get caught, and more than likely they're going to get caught in the pilot tubes of the valve. So never unbraze something from a system, and never cut it out with a hacksaw. Cut it out with tubing cutters. The reason I say don't unbraze is because we have problems with getting oxide buildup on the walls of the copper if we're not using nitrogen, and guys don't tend to use nitrogen when they're unbrazing. I don't know if they just don't think about it or they don't want to use it, but basically when you're unbrazing, you're doing the same thing as brazing, but you just don't have the alloy rod in your hand. So you're still getting up to that temperature, and you're causing oxide buildup. You know, with R22, we didn't have that real problem with that oxide buildup on the walls. We were running lower pressures, and that refrigerant and oil didn't scrub the walls like it does with the 410. Basically what happens is it scrubs the walls, that stuff gets either stuck in your reversing valve, more than likely your TXV piston. And that's why when I pull pistons apart all the time, they got all that black sludge on them, and that's all oxide buildup that's been scrubbed off the walls. So it's only going to get stuck one or two places, and that's this reversing valve or the TXV. So be careful when we're cutting into a system and how we're repairing it. Always use nitrogen. Here is a valve with a spider assembly, or if you're in the field, you can cut farther away from the valve and pull the whole thing out. And then you could take it out to your truck and remove it from this old valve and then reapply these lines. Again, you can request a spider assembly from the factory and we'll put some stubs on it for you. You're going to have less chance of overheating that valve. It's easier to remove the valve and install the new one, and it allows you to braze in a more accessible area. Now you'll have to use some slip couplings, or you can use normal couplings, but you have to sand down that little stop nipple that's inside of it, or else you won't be able to get that coupling on there. So make sure you mark the copper how it was arranged before you remove it from the old valve, just basically so you know how the angles and stuff are for that piping. I'm sure I'm telling you stuff that you may already know, but it's just little things that I've come across in my 20 plus years in the field. Make sure the marks line up with your new valve. You can dry fit it with the marks. Make sure, again, that you're using a wet rag or the paste or your spray gel to keep that valve cool. You know, take your time. Don't overheat that valve. I would, if you ever use a B tank for brazing, which is basically just an acetylene tank, I wouldn't recommend using that at all. The heat, it puts out a lot of heat and it's not pinpointed to a certain location. So I would use your oxyacetylene tanks. Again, slip fitting and braze it into place. Again, if you got a compressor burnout, more than likely that debris is going to get caught somewhere. We would hope that it gets caught in the filter dryer, but more than likely it's going to get in the expansion valve or the reversing valve. And it's our most common reversing valve failure. You know, our reversing valves, we don't have a defrost mode. So we're not shifting that valve back and forth a lot, so we're not wearing it out. Once the thermostat gets put into the cooling position, whether there's a call for cooling or not, O is energized. So until that homeowner puts that thermostat in the off position or back into heating mode, the reversing valve will be energized. It'll stay energized until the end of the cooling season or whenever they turn their system off. So we're not constantly switching that valve back and forth, you know, 3, 4, 5, 6 times a day, depending on defrost cycles. But so that definitely helps us out for sure. So most common reversing valve issue would be on a compressor burnout. So that's what I have for today. I'm not really going to get into these questions here. Let me get to this last slide so you can see my contact information. Again, this is recorded later on today. You can go ahead and look at that recording. Again, technical support phone number 664-5860, and that's the pool back to tech support. There's an email address, so if you have any pictures or videos or something that you want to discuss with one of our technicians, you can email it into technicalservices@enertechgeo.com, and then you can call in and say, hey, I just sent an email, can you take a look at this with me, and you know, whatever you need to do. If there's any more training stuff that you want, if you want this in a PDF format, I can send that over to you. Just shoot me an email and I'll get it sent out to you. But with that, if there's any questions, feel free to ask. If not, I do have, again, I'm doing webinars basically every Wednesday. I'm going to try to continue to do that for a while. Right now, I've got September booked. I haven't put in October's yet, but I will be getting to those probably this week or next. So check out enertechusa.com or enertechuniversity.com. And Enertech University is where you'll find the registration links for the trainings, which you guys may have already found them for today's as well. But you can access that through our secure site or just go to enertechuniversity.com. So with that, if you have anything, let me know. Thanks for joining me, and we'll talk to you soon. Thanks, guys.